Hello, welcome back to the channel. We are going to talk about converting from linear, to non-linear. The other day we talked about converting from non-linear to linear. So if you haven't watched that video, I suggest you go and watch it. Also, if you haven't subscribed yet, now is the time to do so. Thank you. Now let's delve right into it. We have a series of questions that will help us to really grasp what this whole idea is about. We have the first question says that the graph shows part of a straight line obtained by plotting y, against some function of x. For each graph, express y in terms of x. So this is the, let me circle that. This is the question that we are supposed to answer, okay? So if you take the first graph, we do have a straight line, which is plotted within the boundaries of y against s cubed, all right? So if it is a straight line, then in what form is a straight line written? So we know that straight lines are normally in the form y is equal to mx plus c. Now I'm differentiating if you look at it, we have small y, I'm using big Y. We have small x, I'm using big X. Well, I'm differentiating it because even though equation of a line is written in the form y equals mx plus c, these axes are actually not linear like you think, okay? So even though we got it in, we have been able to express this or obtain a curve like a linear, but the whole domain itself isn't a linear, it's a cubic, all right? So we bring in x and y, where the highest power of the x is 1 to ensure that what you have indeed written is a linear. All right, if it is a linear, then it has what? A gradient in this form as m, okay? So how do we find the gradient? Well, we have 2 points here, so we can say m, or the gradient, will be 4 minus 3, okay? Because the point over here is actually 0, 3. Okay, so you have 2 points, one here, one there, to find the gradient. So 4 minus 3 over 5 minus 0. That will give you 1 over 5. Okay, so you found the gradient. That means that you have y is equal to 1/5 x plus c. Now the next thing that you want to do is to find the value of c. Okay, now c is the y-intercept, right? C is the y-intercept, and the y-intercept is 3. So we can just write this as y is equal to 1/5 of x plus 3, okay? But you are not done. Why? Because the question says that express small y in terms of small x, okay? But what do you know from the graph? Well, from the graph, small y is the same. We can compare the graph to what you have here. So you can say that small y is big Y, and then the big X is the S cube, okay? These are the 2 axes that was used in the question. And these ones are our new axes. Okay, so let's do the substitution. So we have small y is equal to 1/5 s cubed plus 3. And indeed, we have expressed small y in terms of x, okay? All right, good. Let's look at another example. So in this case, it's also a straight line, but the axes are different, okay? So always look at the axes. So since it's a straight line, it means we can write it in the form big Y is equal to m big X plus c, all right? So what is the gradient then? Well, we can find the gradient by writing 3 minus 1 over 2 minus 4. This will give us 4 over -2, giving us -2. Okay, so that's the gradient. So we can rewrite it as big Y is equal to -2 big X plus c. But we need to find a value of c. So take one of the coordinates. Maybe we can work with 2, 3. All right, so that will give us 3 is equal to -2 into 2 plus c, giving us 3 plus 4 equals c. So c is what? 7. Okay, if c is 7, then this equation can be written as big Y is equal to negative 2 big X plus c, but c is 7. However, if you look at the curve, we know that small y would represent the big Y, and then the big X is actually 2 to the power x. Okay, so this would change to become, let's put the small y there, then where we have the big X is now 2, so it's basically 2 to the power x, okay, plus 7. And indeed, you have expressed y in terms of x, like that. Okay, now sometimes it wouldn't just be y, it will be something other than y. If you consider what is here is 1 over y, okay? But I mean, it's the same principle. What you are seeing is a straight line. If it's a straight line, then you can write it in the form y is equal to mx plus c. So find the gradient. So the gradient is 6 minus 2 over 5 minus 1, giving us 4 over 4, giving us 1. Okay, so this now becomes y equals x plus c. So let's find the c. Maybe we will use the point 1, 2. So you have 2 equals 1 plus c, giving us c is equal to 1. All right, good. So now this function becomes, now that we have found c, so we have y is equal to x plus 1. Okay, but comparing what we have here with the graph, we can say that our big Y is 1 over y, and then our big X is x squared. So let's put those things here. So we have 1 over y is equal to x squared plus 1. But the question said that we should do what? We should express y, not express 1 over y. Okay, so this is also over 1, okay? So in maths, you can actually flip both of them, okay? Turn everything upside down. So if I write the y first, y over 1, okay? Then I will also write the corresponding y correspond to 1. So I'll write 1 over x squared plus 1. However, y over 1 is basically y. So at this stage, I'm just going to erase it and just write y. Okay, then in this way, I have been able to express y in terms of x. All right, now let's look at this example. Also, pay attention to the axes. The axes are really, really important. If you don't pay attention to that, you will make a mistake. Considering what we have here is a straight line, so write y is equal to mx plus c, okay? Now, what is the gradient? Well, the gradient could be 8 minus 2 over 10 minus 2. That will give you 10 over 8, which is 5 over 4, right? Okay. Now, so that means big Y is equal to 5 over 4x plus c, right? Maybe we want to use 10, 8, okay, to find the constant term or the y-intercept. Okay, so you have 8 is equal to this into bracket 10 plus c, all right? So you have 8 equals 50 over 4 plus c. So c is basically 8 minus 50 over 4. I think that'll give you negative 9 over 2. Let me confirm that on the calculator. 8 minus 50 over 4. Yes, negative 9 over 2. All right. So now this equation here changes a little bit to become big Y is equal to 5 over 4x minus 9 over 2. However, we are not done. Let's go back to the graph. Our big Y corresponds to x plus y, and then our big X corresponds to x squared. All right. So that means that what we have here, okay, we can rewrite it well as x plus y is equal to 5 over 4 x squared minus 9 over 2. But the question said that you are to express, this is it, express y in terms of x. So we are not done yet. We have to express y. So this means that the x here has to go to the other side, all right? And then we will have y is equal to 5 over 4 x squared. Oh no, this is big X. X squared minus x minus 9 over 2. Okay, and this is what we have expressed. All right, we started as a linear and then we have expressed it as a non-linear. Specifically, this is a quadratic. All right, sometimes they wouldn't draw such a thing for you to look on it and know that, oh, it's a straight line, therefore I'm going to use y equals mx plus c and work it out. No, they'll give it to you in a word problem like this. You must decode the keywords and then from there solve it. How do we do that? So we have this question. It says the variables x and y are related so that when this is plotted on the vertical axis, that's really important, okay? And this is also plotted on the horizontal axis. A straight line is formed. Now underline that. A straight line is formed. Now that straight line is passing through this point and that point. Okay, so the instruction for us is to obtain y in terms of what? X. Right, now the fact that this is a straight line means that we can write it as y is equal to mx plus c. Okay, now we need to find the gradient, but we have 2 points here, so we can just do 12 minus 4 over 2 minus 6. That will give us 8 over negative 4 equals negative 2. Okay, so we found the gradient. So that means we have y is equal to negative 2x plus c. We can use this point 12 to help us find the value of c. So this means that we are going to have 12 into bracket, negative 2 into 2 plus c. And that would be 12 plus 4 equals c. C will give us 16, okay? So if c is indeed 16, then we can rewrite this particular equation over here as y is equal to negative 2x plus 16. But this is actually not small y, all right? Not small y in terms of small x. This big y in terms of big X. So we are not done yet. Well, we are told that on the vertical axis, it is y over x squared. So that means that this big y is the same as y over x squared. Now on the horizontal axis, what was plotted there? It was s cubed. So that means that this big X is actually s cubed. Right. Now we can put everything into here and there, and then we'll be fine. So we have y over x squared is equal to negative 2 s cubed plus 16. The question says write y, not y over 2, no, sorry, y over x squared. So multiply through by x squared, that will give you y is equal to negative 2x to the power 5 plus 16x squared. And now, indeed, you have written it in a non-linear form. You are done. Let's consider this last question for today. It says that the variable x and y are plotted in such a way that let me use different color. What we have here is on the vertical line, and then what we do have here is on the horizontal line. We'll come back to this. However, they formed what? A straight line. Like I said, is the most important thing, and it's passing through 2 points, so you can find the gradient. So if it's a straight line, then we can say that we have y is equal to mx plus c. So m will be 9 minus 4 over 8 minus 3, giving us 5 over 5, right? So gradient is 1. So that means that we have y is equal to x plus c. Let's use the 0.34, this 0.34, to find the value of c. So we have 4 is equal to 3 plus c. C is definitely 1. Okay, now if c is 1, then that means that this curve or this equation can be written fully as y equals x plus 1. Okay, well, so now that we have this, the next thing that we want to do is to go back and check what is on the vertical line. Well, on the vertical line, we have e to the power y. So that means that our big Y is e to the power y, and then our big X will be what? We check on the horizontal, plotted on the horizontal, what was plotted? X squared. So this big X is actually small x squared. So that means we can modify this particular equation. So that will give us e to the power y is equal to x squared plus 1. Well, if you check the A, they said that express e to the power y in terms of x, and that is exactly what we've done. Okay, so that's for A. B says that we should do what? It says express y in terms of x, so now make y the subject. Okay, so if you are going to make y the subject, we have e to the power y is equal to x squared plus 1. So what you want to do is that since it's an exponential function, okay, just take the ln of both sides. So we will have ln e to the power y is equal to ln into brackets x squared plus 1. All right, and this will give us y is equal to ln x squared plus 1. And that is what you are supposed to achieve when you express y in terms of x. And this is definitely a non-linear. So to summarize our study today, if you are given questions like these, identify keywords. The keyword here is straight line. So just find the gradient and find the intercept. If you find the gradient and the intercept, now go back to the question and look for what is on the vertical line, what is on the horizontal line. After identifying your vertical and horizontal axis, go back and do the substitution, and then you'll be good to go. Stay safe until we meet again. Keep learning maths. Bye for now.